knife triangles. Do you remember what the triangles, or shall we do a little bit of recap?
A little bit for recap.
Yeah, alright. So what's a triangle? A triangle is just basically a shape formed out of three lines. You do have
that all of the angles add up to 180.
yeah, this angle plus this angle plus this angle every time is 180. Doesn't matter which shape is for triangle. It can be like this. It can be either like this. Every time is 180. Alright.
Okay.
One more thing. You do have three type. You can classify your triangle based on the angles and based on the sides. So let's try first with the angles. So you can classify in three types. First is the right triangle. The right triangle just has one angle that is a 90°. Second is isosceles triangle, which basically two angles are the same. And the last is equilateral triangle. All the angles are the same. And actually I think there's a fourth one where none of the angles are the same. Alright? So again, this one is called scalene. No, this one is called right triangle because one angle is 90°. This one is called scalene. Scalene basically means none of the angles are equal. This one is isosceles. This one is I don't know how to pronounce it in English. Equilateral or something like that, right?
Equilateral.
Yeah. Then you have it by sides. Actually, it's kind of the same thing. If all of the sides are equals, it's the equilateral one. If only two sides are equal, it's the isosceles one. And if none of the sides are equal with each other, then it's a scalene. And yeah, and we learned some formulas. So basically all of them, we did apply them in the right triangle, but they can be applied in any triangle, but it depends. All right, it depends if it's like so. First, the Pythagorean theorem. In order to apply the Pythagorean theorem, you must have a 90° triangle. Otherwise, it doesn't work. You must have a 90° triangle, something like that. Or for instance, if an is an isosceles triangle, you just take the height of it, then ta-da, you form a 90° triangle, which is this one. All right. So just for that, let's just recap. So for Pythagorean theorem, first of all, this one is called hypotenuse. This one is called the first leg, so leg 1. And this one is called the second leg, leg 2. Alright? Now, what does Pythagorean tell you? That a to the second power plus b to the second power equals with c to the second power. In English, first leg to the second power plus the second leg to the second power equals with a hypotenuse to the second power. Got it?
C.
Alright. Now you do have three important lines in a triangle, which is a bisector. The bisector just splits the angle in half. So if you have an angle, you take a bisector like this. This angle is gonna be equal with this angle. Alright? As an example, you have an angle, it's 80°. If you take the bisector, it's gonna split that angle in two angles that are how many degree?
In half of his degree, so 80, the bisector of 80 would be 40.
40 and 40, right? If you take the bisector, 40 and 40. Okay. Follow the bisector, you do have a height. The height is kind of just simple. Every time it just forms a 90° angle. So it doesn't matter where it falls into, it must fall a 90° angle. You might have it just like that. So this is the height. You might have it like this. This is the height. Or I don't know, let's try. So with an equilateral one. So this can be the height. This can be the height. And this also can be the height. The tricky thing of it is just it forms a 90° angle on the side that falls to. Got it?
Mm-hmm.
Alright. Next, you do have a median. If a bisector splits the angle in two halves, the median just splits the side that falls into two halves. So if it goes like this, it splits it like that. Alright? If it goes, I don't know, like this, then it splits like that. It splits the side that falls into two parts. Alright?
Alright.
And if I don't remember, we also learned about a new theory. Again, is called 30° theory, which basically tells you if you have a right triangle and one angle is a 30°, then okay, so I'm gonna do it like this: A, B, and C. Then the side that's the leg that is opposite to a 30-degree angle. So what's it? What it's leg A, right?
Yeah.
A is going to be half of hypotenuse, so C over 2. That's a 30-degree angle. Fury, okay?
Alright.
And again, I think we do have it on height. Yeah, let me just double check it if I told it to you. I think I did. Yeah. So about the height, you have a right triangle. You take the height of it like this, right? So the height is basic. So A, B, and C. The height is going to be the first leg times the second leg over the hypotenuse. All right. Use the theory of the height. And also, but I'm not sure. Let me double check it. All right. Also, the height to the second power. Okay, so I think I'm gonna make a new drawing here. You do have a right triangle, so here it is. You take the height, it forms a 90-degree angle, right? And let's say it's split level, so you have a triangle A, B, and C, and the height falls on this angle K, right? Then AK to the second power is going to be equal with P.
K to this BK times KC.
KC, right? So that's another theory of it. All right, you remember it. And now, shall we? Yeah. So that's also the theory of the leg. Again, think about you have a right triangle. I'm gonna draw it like this just for you to see it more simple. You have a right triangle.
Not a right triangle, but okay.
It's a right triangle. It has a 90-degree here. Okay?
Okay.
Now take the height of it, and again we're gonna note it A, B, C, and K here. All right. Now, if you want to find the leg, keep in mind AB is the leg and BC is also the leg. So here's the leg, because the legs are the ones that are adjacent to the 90-degree angle. All right.
Yeah.
So if you want to find the leg, in our case, let's say AB. AB to the second power is going to be equal with the whole hypotenuse, which is AC, times its projection on the hypotenuse. What does projection means? Think about AB as being like a pencil, and you're holding on the table on this angle. I don't know, let's say it's an angle right here, right? Now, that pencil is gonna form a shadow on the table. Now, that shadow on the table is basically AK, okay? That's called a projection, all right?
Okay.
So, AB equal with the whole hypotenuse times its projection, which is AK. Now, for BC square, can you tell me the formula for it?
BC squared.
Yeah, if you want to find
BC squared, same thing. Except it would be AC or CA times AK. No, CK.
Yeah. The projection of BC is this one. For this one is this one. Alright? And now that's every formula that we need to, and I think we can start. So it was I think it was a fast recap. We took like 9 minutes. Are you alright on this? On this theory?
I'm okay.
Alright, if you are, then we can start then. So 11? Oh damn, can you see it actually, or should I make it like a little bit bigger?
I can see it. It's not the best, but I can.
Yeah, I know how to do it. Okay, try to solve this one then.
Yeah, in a triangle, one angle equals 30 degrees. The median corresponding to the hypotenuse has a length of 5 centimeters. Find the length of the sides of the triangle. So we have a right triangle or
Hold on, what? Fine. Go. Oh. Yeah. I didn't give to the AI the full exercises and it translated wrong, so let's skip it. I don't know what 12
okay.
right away. Okay, 12. So we do have 10 exercises to solve. We finish it and we're done. Alright?
Okay.
Okay, man. Start from the easy part.
Okay, find the length of the sides of a right triangle, knowing the height of and the median corresponding to the hypotenuse, has the length of 8 centimeters. Wait, what? Find the lengths of the sides of a right triangle. So we have a right triangle, and the height, and the median corresponding to hypotenuse have lengths of 8. Okay, so AB is 8, BC is 10.
Not really. It tells you that the height.
And the median.
Yeah, so I don't know. Let BK be the height, right? And the median to be BS, alright? So the median splits this thing in two, right?
Alright.
Now you can just apply the formulas for each of them, for each of those. You know.
Okay. Wait, I'm kind of wait. It's saying that AK is 8 and C and KC is 10 or what?
No, it's telling that BK is 8 and the BS is 10.
So BS is 10 and BK is 8. Okay. What do we do first?
Hold on, this problem is actually. Yeah, it's interesting. It's actually very interesting. Alright, man. So you know AB is the leg, right?
Yeah.
BC is also the leg, right?
Mm-hmm.
AC is the hypotenuse, right?
Yeah.
Now, your height. So, I'm gonna. Sorry. I'll do like this. Your height, it's BK, right?
Yeah. Which is 8.
Which is 8, right? Now, your median, I'm gonna do it by M, is BS, right? Which is
10.
10. Now, do you know the formula for the area in a right triangle?
I'm pretty sure. No, I know the area for a circle, but not a right triangle. But not a right triangle.
Yeah. So for the okay, do you know the area for a square?
Oh, I remember. It's a third BH. 1/3 BH.
Yeah, that's for the cone. That's for the cone.
A big B and H.
Yeah, that's for the shape like a cone or stuff like that. I mean, I'm telling you for a square.
For a square, it's just BH.
Yeah, so you just multiply them. Now, but a triangle is just half of a square. So if you make a sandwich, a triangle is just half of a square.
It wouldn't be 1/3. It would be half. So.
Yeah, so it will be the first side, AB, times the second one, BC, over 2. Alright?
Okay. So we're gonna have to find the legs.
Yeah.
What's the formula for it again? I kind of forgot.
Hold a moment. Yeah, let me think about this problem too then.
No, wait, have we learned about the median yet?
Yeah, we did learn about the median.
I kind of forgot its purpose.
Yeah, it's just split the side that falls into 2 half and that's it.
Wait, so it's just taking the height and folding it into...
Okay, most probably there was also theory for the median. Yeah, there is. So a new formula for you, just keep it in mind and note it somewhere. For the median, I'm gonna go back where we talk about the median. Okay, so the median, right? Again, you have a right triangle. It's like this, which is A, B, and C, right? Now you take the median, which is M, right? AM. Now, what does the median do? It splits the side that falls into 2 parts equal with each other. Alright?
Alright.
Now, if it's split into 2 parts, there's also theory of median. It tells you that AM, the median, is going to be equal with hypotenuse over 2. BC over 2. Alright? So basically all of these 3 sides are equal with each other. Now if we go back to our problem, here. We know that BS represent the median, right?
Yeah.
If it's the median, then BS is going to be half of a hypotenuse, which is AC over 2, right?
Yeah.
Now, our median, how long it is?
Our median is 10.
10. So 10 equals with AC over 2. From this, it's resolved that our hypotenuse AC is going to be?
It's going to be 10. 5.
So 5 over 2 is 10.
Yeah.
5 over
20.
20. Yeah. So we found our hypotenuse. Oh my. No. Hold on, I'm gonna pause the lesson. We're gonna start again. So AC is 20. Right?
Yeah.
Okay, so we know AC is 20. Now, what we can do?
We can... If we know that AC is 20, then we can... we can solve BC? No, we already did. Wait, what?
No, with BS you just stop already. It's no more need. What you need to find the length of a side. Oh yeah, so you need to find AB and BC now. You know that the whole AC, so this whole part is 20. You already found it. I think I can draw the drawing differently and you'll be able to see it. So I'm gonna put it like this. So here's your height. Okay, so you know that the height is how much? 8, right?
Yeah.
And you know that the whole AC is 20. Do you see something?
We can find a... now we can know that AK and KC are both 10.
Not really. The height doesn't split the angle into 2 parts. The median does that.
the median.
Alright, man. So here's two formulas. You also need to know them. So the area for the triangle, it can be one leg times another leg over 2, or can also be area of a triangle. It can also be the hypotenuse times its height over 2. Okay?
The thing is, I never knew that, so that's fun.
Yeah.
Uh,
Now just look, you can just make them equal with each other, both of them. So you can say A times B over 2 can be equal with C times H over 2. Now A, what's your A? AB, right?
yeah. My AB over 2 equals C,
AB times B is?
oh, wait, you said, what? A times B?
A times B, but this is just the legs. I'm gonna denote that out.
Yeah.
So the general denotation, you know. B
Okay.
is the second leg. Your second leg is?
Yes, my second leg is 8. No, that's fine.
So here's the 90-degree angle. So AB,
90.
AB is the first leg, BC
Yeah.
is the second leg. Okay?
Okay.
It can be equal with C is the hypotenuse. In your case, the hypotenuse is AC, right? Times the height, BK. Okay?
Okay.
So now AB times BC is?
AB times BC is so it's leg times leg. Do we know the legs or no?
Do you know the AC? You know it. You just apply it. You just find it out here. Which is 20.
20.
But the height is?
The height is 8.
It's 8. So the product of the legs AB times BC is?
It's 160.
106. Okay. So this is the first equation. Now, but for the second equation, you're gonna find it by yourself. Again, you just have a right triangle, the same right triangle, but I'm gonna note it again here. And what was the notation? So A, B, C. A, B, and C. Can you apply the Pythagorean theory?
Yes.
Okay, what you have?
We have both the legs, which are 80 and 80. AB and BC are 80.
So AB.
AB squared plus BC squared equals AC squared.
Okay. Now AB squared plus BC squared equals?
Hypotenuse.
Yeah, but you know the AC. AC for you is? You found it.
AC is 20.
So 20 to the second power, right? Now AB squared plus BC squared is?
20, wait, 2 times 2, so 400.
400. Okay, cool. So now here's your next equation. And you already have two equations, which basically means you can make a system. So for the first equation, what it was? It was AB. AB times BC equals 160.
Yes.
160. And AB square plus BC square equals
40. I mean 400.
400. Yeah. I'm gonna blow your mind. Sorry. I don't know what's going on with this problem, but it's actually.
No, because like first I forgot what median is, and then I had to relearn it, and then I'm just, god damn it.
Okay, so look. Do you know what? Do you remember that formula, which is a
Where we
plus?
like substitute or something.
Yeah, a plus b to the second power. Do you remember it?
It equals AB times
It equals a to the second power plus two
B
ab
times 2.
plus b to the second power, right?
Okay.
Now just instead of a and b, just put your your legs. ab plus bc to the second number to the second power is
Is okay. Wait. So it wouldn't be AB squared times plus 2 AB times BC plus BC squared.
yeah. And right now, look what I'm gonna do. I'm gonna rearrange that. ab square plus bc square plus 2 ab times bc. Now ab square plus bc square is, you have it here,
It's 400.
400 plus
100 and no, but so wait, one. But if it's 2AB, wait, 180. So if it's two, wait,
if it's 1/6 is for ab times bc, but for 2 ab times bc is 2 times 1/6, which is 320. Okay, now you know that ab plus bc square equals with
320. No, 720.
720. Now only ab plus bc.
AB plus BC equals 160.
Careful, square root of 720. Okay,
And then the square root of 720 is.
yeah, look, you cannot, like, usually, yeah, in US you can use a calculator, but here
26 point, yeah, it's.
yeah, here what you're supposed to do is 144 times 5, which is 720. Now the square root of 144 is 12, square root of 5. Alright?
Alright.
So let's see, here's our third equation too. So we had 2 here. We know that AB plus BC is 12 square root of 5. We know that AB times BC is 160. Yeah, alright. Did that got easier or not? I don't think so. Okay. Alright, now let's solve this one. No, actually right now we're gonna solve the system. So AB plus BC equals with 12 square root of 5, and AB times BC is 160? Yeah, 160. Now solve the system. AB is
AB, okay, AB equals.
so if you know AB times BC is 160, only AB is
Then it would be what 4? You can say 4.
160
40
over
times.
BC. Man, it's 160 over BC. If one number times another number is 160, right? But only the first number is going to be 160 over the second number, over BC. Alright?
Alright.
Now, here, in the first equation, instead of AB, just put 160 over BC. Okay?
Alright.
So what you will have?
You will have 160 160 divided by. And I
BC.
can't think.
160 over BC plus
BC
equals
12 square root of 5.
square root of 5, yeah. And now just solve this equation. 160 solve it.
I guess you can multiply by BC to get rid of a fraction, so now you're just left with 160 plus 2 BC
Plus BC to the second power.
to the second power equals 12 square root of 5. And then you flip it to the so BC squared would equal 148 square root of 5. Or
Yeah, just look, just solve a second degree equation. Remember we did that in algebra class. Instead, look, I think it's going to be easier for you. Instead of x to the second power, or actually 12. Okay. Yeah, alright, so solve away what you wanted. So BC is?
BC squared equals 148 square root of 5.
12 square root of 5 minus 1/6. Okay? First is this one, then
BC,
I'm really trying to think if this is gonna make sense or not. Can you just check how much is square root of 5?
it's not a solid number.
Yeah, it's not a solid number. Can you check it?
Okay, it's a 2.23.
Yeah, somewhere we did a mistake then. BC times BC. Oh, yeah. 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 So look, man. Yeah. You multiplied this equation by BC, right?
Yeah.
But
did we forget to multiply 12 to the square root of 5 by BC?
Yeah. We forgot that. And now I think you also can say it. So BC squared minus 12 square root of 5 BC plus 160 equals with 0. Now your x is just BC, and you need to solve a second degree equation with delta. Alright?
So now we're using delta. Okay. Delta equals 4b b squared minus 4 ac. So delta equals negative 12 square root of 5 bc.
Only that. BC is your x, okay?
Squared minus 4 times 1 times 160. Delta equals negative 12 square root of.
Yeah,
wait,
just.
Since we're. Does that we can get rid of a. Can we get rid of a. What's it called again?
What? No, so what's negative 12 square? 144, right?
Yeah.
And square root of 5 square is 5.
Yeah, so we can make it into negative 144.
Careful. When you raise to the second power, the negative sign disappears because it's minus times minus, right?
So 144, and then 5 and then square root of 5 would just turn into 5, so it would be 144 times 5.
5, yeah, minus
Um, negative 16 times 4 is 48, so negative 480.
Careful.
15. No.
No, because 160 plus
Oh, it's
160 is
60, not okay. So 40, 106. So it would be four. Okay, so it would be 400 plus 400.
Come on, man. What's 160 times 4?
God damn it. Okay, 100 times 4 is 400. 60 times 4 is 24. So 460 is 640.
640, yeah. Now 144 times 5?
Can I use the calculator? No.
Nah, you use the multiplication in column.
Okay, 540. Okay,
5 times 4?
40 times 5 is 221. So
Yeah, man, look.
720?
Yeah, it's 720. Because 5 times 4 is 0, 0 say, put 2 in mind, 5 times 4 is 20 again, with 2 in mind is 2, you put it 2 in mind again, 5 times 1 is 5, with a 2 in mind is 720. So 720 minus 640, which is?
Which is no, yeah, I could specify that in 80.
Yeah, it's 80.
Not gonna lie, I completely guessed 80. I just looked at it and thought that makes the most sense.
Now x1, or actually bc1.
BC1.
Mm-hmm.
Okay, BC1 would be, wait, it's higher, so that means there would be two equations. So it would be, what was the formula again? It was, B,
Minus b.
Minus B, and then something, and then I
Plus
think it was,
square root of delta over
square root
2a.
of delta, yeah, over 2a.
I think we're gonna do only 3 problems today.
Why?
If all of them are like this.
Yeah.
Alright, and that's going to be?
That's going to be, okay, negative b. So, positive 12 square root of 5.
Yeah. Plus?
Plus, okay, plus.
Yeah, square root of delta, okay?
Is 80, so square root of 80 is,
Careful, here 80 you can divide it in square root of, I guess, 20?
Square root of 40 times 2.
Hold on. 16 times 5, okay? Which is 4 square root of 5.
Yes, 4 square root of 5. Over 2 times 1.
Yeah. Now BC1 is
16 or no, yeah, 16.
square.
Can you add the square? No, I don't think you can.
Yeah, you can. You just save the square root of 5 as common factor, and you just have 12 plus 4, which is 16. And I think you can now divide it. You can simplify 2 with 16.
That's just 8.
8 square root of 5. Yeah. Now, why you can do that? Don't think about 12 square root of 5 as just one number. No, think about it like 12 times square root of 5.
Alright.
Alright? Now for the second one, so BC2.
BC2, same thing except it's minus the square root of delta.
Which is?
Which is okay. You add them, you minus them, so now it would be 8 square root of 5.
Over 2, which is?
Over 2, okay, 4
4 square root of 5. Yeah. So look, we have two choices. It's either 8 square root of 5 or it's either 4 square root of 5. Now if we go up and we say BC is 8 square root of 5, that means AB is going to be 4 square root of 5. If we say BC is 4 square root of 5, then AB is going to be 8 because this one needs to add up to 12. Alright? So basically we just find both of them. It's either AB is 8 square root of 5 and BC is 4 square root of 5, or the other way around. BC is 8 square root of 5 and AB is 4 square root of 5. So basically this is our answer. This is for the first, this is for the second. It can be either both of them. Doesn't matter which one. Alright?
Okay.
Did you like the problem?
One long ass problem.
Yeah, it was one. Okay, let us see if
Okay,
even next one is also like this. Okay, 13.
Is this our second problem of the day?
Yeah.
Oh my god. How did we go from triangle to delta? How did that happen? Consider triangle ABC with AB equals AC and the point E, AC and FAB, given that I don't even remember what that 2 slashes means.
Which ones?
Next to
Oh, the module.
yeah, the module.
Prove. Now we need to prove actually.
Oh my god, it.
What?
Nope, nothing.
What?
Nothing. Okay, anyway, consider a triangle ABC with AB equals AC and points E. Okay, bullshit. Given that prove that AB equals AC.
Alright.
We have a right triangle, I'm guessing.
It's not a right triangle though, it's just...
Isosceles?
Yeah, because two sides are equal with each other, right?
So we have an isosceles triangle, the legs are the same, which is AB and AC. So we have yeah.
So it's like this.
Yeah. We have A, B, C. Like that,
Now the point E belongs to the leg AC. Okay, so here's
so
E.
E is AC, F is AB. Given that CE equals BF,
So
prove that the angle of AEB equals the angle of AFC.
A E B A F A E. Oh.
AEB and AFC. We're going across the triangle. Fun.
So like this, right?
You just meet at the middle point. Nah, that's not gonna work.
Yeah. So what is telling you? You need to prove that the angle AEB. So this one is the same as AFC. All right.
Yeah.
Man, let's just denote everything that we know, and we're gonna take it from that, okay? From every problem that we know. So it told you that BF equals AEC, right? Note that down. BF equals with AC. All right? And you know AB equals with AC. Well, actually that doesn't matter anymore. Okay. what does it mean if triangle ABC has, okay, so AB, okay, I'm gonna note that down. AB equals with AC. Actually, okay, so I'm gonna teach you how to how to prove it. So you know from the problem that AB equals with AC. That results that the triangle ABC is what type of triangle?
That ABC is.
You just told me at the beginning of the problem. You told me what type of triangle it is.
It's an isosceles.
It's isosceles. Now, if ABC, triangle ABC, is an isosceles, right?
Mm-hmm.
What does it mean? The property of an isosceles triangle. So you know that you know that the sides are equal, and also the angle at the base are also equal with each other. All right.
Yes.
So the angle ABC is equal with which angle?
ABC is equal to ACB.
ACB, right. The angle at the base are equal with each other. All right. Now let's kind of try to make it easier for us. I'm gonna make my marker to be smaller because we're gonna have a lot to. All right. So you know from the problem that CE equals with BF. All right. Now let's just say that it's going to be equal with, I don't know, K. That is just some random number, some number, okay? We don't know it, we need to find it out. It's just some number for us to just do the calculation, okay? Equal with K, all right?
Alright.
Now, you know that E, it's on AC, right? Now, if you know E is on AC, you can say that AE is going to be equal with
AE is going to be equal with AF.
AA. Okay, so only this, right? AE
Yeah.
equals to the whole AC minus EC, right?
Okay.
So again, tell me, AE equals with
EC or CE?
yeah, AC minus
EC.
EC, right? But you also know that EC is K, so you can just simply say AC minus K. Okay? Now, what about AF?
About the same thing. So AF equals AF minus FE. Or
Careful.
is that not it? AF.
AF is AB.
Oh, AB minus AF.
BF.
Or FB. What am I saying?
Now you can say AB minus K, right?
Yup.
Okay. You know that AB equals with AC, right? Because in it's a isosceles triangle. Yes?
Yes.
So, if okay, do you follow me until now? Is everything clear till now?
I'm just kind of like confused how to do this.
Why?
So if AB equals AC is delta, no, it's the area. ABC is isosceles. Are we trying to again? We're trying to find we're trying to find the angle AB. No, prove that the angle AB equals ASC, right? So
look what I want to do right now. I want just to show that not only BF equals AC, but also AF equals with AE. Okay?
Okay.
How to say E from elephant? It's like E, right?
E.
Yeah,
Elephant.
okay. AE. So right now I'm
Elephant. Elephant.
yeah,
Elephant.
okay.
Eh.
So you know that AB equals with AC. It's isosceles triangle property, right?
Yeah.
That means that A elephant, okay, so AE is going to be equal with, we proven that it's AC minus K, right?
Yeah.
And can also be equal with AB minus K, which is basic AB minus K is our EF. Okay, follow me along here. You know that AB equals with AC because it's an isosceles triangle. If AB equals AC, AE, we said that is AC minus K, and is the same thing as AB minus K, because AB and AC are equal with each other. They're an isosceles triangle, okay? So this thing and this thing are both the same. We can just flip them around, okay?
Okay. So also AB and AC they're basically the same thing because
Yeah.
they're both part of a.
Yeah, because those are the two sides that are equal with each other in an isosceles triangle. Got it?
Got it.
Now we know that AB minus K is our EF, right? We just show it here, right? So if you just follow this log S equation, you can say that AE is also equal with AF. Understood?
Understood.
All right. So now that's our main point that we got. So this is our first thing. So I'm gonna not fix 1. Now, just a quick recap. From a problem we got that BF equals with AC. We just found out that we just showed that also E elephant equals with AF. All right.
All right.
Now, okay, can I just copy this thing? Hold on. Okay. Man, look in this triangle. Look in the triangle A, E, and B.
Yeah.
And
Triangle
also
A,
look in
B.
the triangle A, F, and C.
AFC. They
So you know
Hold on.
that AE, right, from the triangle
Yeah.
AB equals with AF. We just showed above, right?
Yeah.
So AE, this thing, equals with AF, this thing, right? Now look at this angle. The angle EAB and FAC are even the same angle.
Yeah.
Yeah, so that's basically mean the same, right?
Mhm.
So if you know that two sides are equal with each other, they have the same angle, that basically means that the thing that remains, AB, equals with, so you also know that AB equals with AC, alright? So you have three conditions. Now, I'm gonna don't note this down again. So you have an isosceles triangle, A, B, and C. Here's your point, here's F, here's E. So you have like this, and you have like this. Now, you know that AE, so this thing equals with
AE equal, wait, what?
Hold on, I think I can do it better for you to understand. Control K, PAM, Control V, Control back. Okay, so I just split it into triangle. They're the same, but just for you to understand. Alright? Look, AE, AE, this thing. Right?
Mm-hmm. Yeah, I get it. They're all equal.
Yeah, I'm just trying to show you visually. So here is the triangle AEB. Look at the triangle. But here, look at the triangle AFB. Okay?
Okay.
Now look, AE equals with AF. So these two are equal with each other. EAB equals with FAC. So these angles are the same angle. And you also know that AB, so this thing equals with AC. Okay, AC, AB. So these one are also equal with each other, right?
Yeah.
Now, from the theory, if you have side, angle, side, if you have two triangles and they both share this thing, side, angle, side, in this order, both sides are equal to each other, they share the same angle, and this of another side is equal to each other, that means that the both of those two triangles are congruent, meaning they're the same. Alright?
Yes.
So we just show that. So that means that the triangle EFB is the same thing as the triangle AEB. Alright?
Mm-hmm.
Now, if they are the same, that basically means that the angle EAEB is equal with the angle AFC. If the triangle are both the same, that means the angles are also the same. Okay. Does your brain kind of starts on fire?
Yes, a little bit.
Okay. Let's try to get from the beginning. Try to like get through this problem and tell me where you lose, like where you stop understanding.
Okay. Okay. So, at the very beginning, we're trying to prove that AEB equals the angle AB equals the angle AFC.
Yeah.
We know it's an isosceles triangle, and we put down the numbers F and E in the middle, and then we prove it that that they're the same by showing that AE equals AC minus EC or AC minus K is the same as AF equals AB minus BF, which is also the same as AB minus K.
Yeah. What you did next?
Oh, and then we put it together. So AE equals AC minus K equals AB minus K equals AF. It shows that they are the exact same thing. No, AE and AF are the same. AC minus K and AB minus K are also the same thing.
Yeah, so that's basically show that you have two triangles that are the same triangle, right? They're the same triangle, but they're just, I don't know, flip around. Okay? So if
Alright.
they're the same, that means the angles are also the same. Everything inside them are equal with each other. Man, I really don't know if you're gonna have this kind of problem in high school.
I'm not even sure. Cause here's the thing, every year, the school changes the curriculum.
Yeah, I mean, look, this is like geometry, and I learned geometry watching US teachers.
Mm.
So I know that you know about SAS, side angle side. I know about it. So the last part that we did, side angle side, I know that you do the bisector, median and height 100%. But I'm not sure if you have that complex of problems.
Like what? Like these type of complicated
Yeah,
problems?
it's not complicated, it's like, so let's say you have three levels, A, B and C. C being the most complex one, A being the most simplest one.
Then
This
this
is
would
the
be
middle.
like B.
Yeah, this is the middle one.
Yeah, I still haven't learned. Yeah.
Yeah. I think, look, you know what we're gonna do? We're gonna stick with the A type of problems for a while until you're gonna learn geometry in high school in US. After you learn geometry in high school in US next year, we're gonna move to the B tier problems. Sound fair?
Okay.
I just showed you today like a couple of them. Two actually. Oh my god, it took
You
us
showed two C equations and I didn't understand a single thing.
1 hour it took us for two problems.
Yeah. I really didn't understand a single thing. It was so. It was just so much happening. Like the first one we went from like solving the hypotenuse or something into delta solving, and we ended up like we ended up like
Yeah,
weird numbers.
yeah, I know. I just wanted to like try to push you a little bit,
And
but
you see that that was not the best idea.
yeah, but that's not the best idea, and I know why. I know why. So we did only like 2 lessons on geometry. I mean, I'm gonna tell you how much we did on geometry. Yeah. So look, we did only 1 lesson on triangles. Two lessons on triangles.
We did 2 lessons on triangle, and then you gave me two C level problems,
B level problem. Yeah.
B level problems.
Yeah. So yeah. So look, we're gonna just stick around with the A type of problems for a while, and then we're gonna move it to the B maybe next year. All right.
All right.
All right, man. Then we're gonna stop today. Okay. Let me just stop
Okay.
recording too.